Hello, my name is Jared Gardner, and this is my project, the Frostodon. Every year, when ice fishing season rolls around, my wife has one rule, that I don't go ice fishing alone. And it makes sense. With freezing temperatures, remote locations, thin spots in the ice, the situation can quickly change from fun to deadly. But it can be tricky to find someone willing to brave the elements with me. That's why I created the Frostodon, an autonomous lake ice tester. To make it clear what the ice conditions are before ever setting foot on the frozen lake. To give my wife some peace of mind. Sadly, we've had a bit of a heat wave this December, so I don't have very much footage of this in action on the ice. To make do, I picked up some block ice to demonstrate on. The Frostodon was designed to run autonomously while I suit up and load my gear into the sled. When I reached the lake, I placed the robot on the edge of the ice in the direction I wanted to test. After powering on the robot and remote, I wait for the USB 32 boards to connect. I used these development boards instead of Arduino to take advantage of the built-in Wi-Fi, higher bit rate, and small size. After they connect, the LCD prompts the user to input a distance and then the number of tests using the pound key to enter each value. The robot then displays the two entered values and prompts the user to press A to start. If needed, the user can press B to re-enter the values. Once A is pressed, the robot and remote both begin a countdown, then switch into the auto state. In the auto state, a map is displayed of each test. It's hard to see because of the nature of the OLED, but there at the bottom of the screen you can see the first test showing up as a blank circle. Now the robot calculates the error between the desired distance and the current location. The robot uses this value in a PID controller to drive two brushless DC motors. It will travel to within about 4 inches of the goal, using an encoder to measure the physical distance traveled. If the robot begins to veer off course along the way, the compass kicks in a second PID value to adjust the speed of either the left or right track, keeping it in line with the original heading. When the robot reaches its goal, it switches into the drill state. In the drill state, the robot uses a Harbor Freight drill, stepper motor, and force resistor to test the ice thickness. Force resistor is similar to the photoresistor, only it changes resistance based on pressure. It won't give you an exact weight like a load cell would, but it does sense anything from a light touch to a firm squeeze. When the drill reaches the ice surface, this inner part, printed in red, shifts upward, pressing on the force resistor. The ESP then registers that pressure as the ice surface and sets it as the 0 point. Now the robot powers on the drill using a high amp H-bridge called a BTS 7960 and stepper motor controlled through a DRV 8825 driver lowers a ½ inch at a time, waiting for the value from the force resistor to drop below a threshold before continuing to drill the next ½ inch. It repeats this process until it reaches a depth of 3 inches, at which point it turns off the drill and lowers past the last drilled point. If no pressure is read, the robot reads it as a fail and prompts the user to input either left, right, or retest. If there is pressure, the robot reads it as a pass, sends the result back to the remote to be recorded in the map, and then continues on to the next test. When all tests are complete, you should have a map of all the test points, giving you the assurance that the ice won't disappear from under you. At any point of the robot's operation, you can flip the switch on top of the remote to take manual control. You can then use the joystick on the remote to steer the robot away from danger, or test a spot of ice that looks suspicious. Overall, this has been a super fun project, with 1,300 lines of code and nearly 100 custom parts. It definitely has been a challenge and has stretched me a lot. I've loved this experience and excited to see where I can take this next.